Yeah, so as Claire mentioned, this is a tutorial where we're going to be talking about the Tapis project and about machine learning workflows and how you can use Tapis and other tools to accomplish machine learning enabled workflows in your research. Um, so I'm joined by this team here, Gilbert, Annika, and Christian, who are all in the Cloud and Interactive Computing group, which I manage at TAC, the Texas Advanced Computing Center at UT Austin. Um, and so, this is going to largely be a hands-on lab or workshop. Um, and and so we will do a mix of sort of slides and presentations and then hands-on components. But the overall objective and outcomes for the workshop today are to kind of get you familiar with and associated with kind of various challenges related to computational research. And we'll talk a little bit about just at a high level what those challenges are, and some of the tools that we have available to us for tackling these challenges. We're going to spend a fair amount of time talking about Tapis, which is a project that we co-develop with actually multiple groups now, primarily the University of Hawaii, but UC San Diego and the San Diego Supercomputer Center have been collaborating with us on Tapis over the last few years, and then more recently, a number of other institutions that are part of the ICICLE AI Institute, which I will mention a bit on later. But Tapis is a tool for computational research, which we think can be valuable, and so we'll be talking about that. And then we'll be talking about NLP. And that's just one kind of particular field of machine learning, AI and machine learning that's been taking off lately. I'm sure everyone is aware of all of the advances that are going on there. But we thought we would give a little sort of introduction to NLP. We will talk about transformers and the associated transformer library. So the architecture as well as the library from Hugging Face. And then, we'll try to kind of talk to you about how you can bring all this together and use Tapis APIs for doing machine learning in your own research. So that's kind of the objectives that we have. And all of the course materials that we're going to be going through today are online. So I'll pause here for a minute so that you can get this URL. It'll bring you to a page like this. And I think I've shared the whole window. So you should now see um, the GitHub pages site with the materials. And let me see. I'm going to also try to monitor things here. Oh, Christian has thrown the link in the chat as well. So that's great. Thank you, Christian. Yeah, but so we're going to be going through going through the materials that are available here online. And if we want to just scoot over here for a minute and take a look at the schedule, let's see, is this right? I think maybe the times are in Eastern, but I think basically the times are right, modulo some time zone shift. So basically, like I said, it's going to be a mix of sort of discussion, kind of presentation, and then hands-on exercises. I'm going to begin by talking to you a little bit about Tapis, just sort of giving you the context for Tapis, what it is at a high level, what the objectives are. And then we'll move to a unit on a module on Tapis authentication, which is the very first thing you have to do. You have to be able to authenticate with Tapis and then create what's called a Tapis system. Then we'll take a break, and then I'll come back and talk to you a little bit about NLP and the transformer architecture before we go on to, again, another hands-on lab where we talk about how to do sentiment analysis in Tapis. And then Christian's going to show you some of the Tapis APIs that are useful for machine learning work. So that's the basic agenda. And let's see here. Do we have any questions or high-level comments before we get going?
I don't see any questions, Joe, so maybe we can get started.
Okay, great. Yeah, so I will begin, like I say, with a sort of giving you an overview of Tapis and kind of setting the stage, the context for the project, and so this will be a sort of presentation portion, but we do very much want and intend for this to be interactive. So please feel free to interrupt me during the presentation if you have questions or comments. You can put messages in the chat. You can just also feel free to unmute and ask questions directly. But so yeah, let's talk a little bit about why do we have Tapis? What's the goal here? So to begin, we really do have this sort of large ecosystem of cyber infrastructure across the U.S. and even internationally, and it provides this sort of powerful set of tools and capabilities for research computing. Right? I think that's without doubt. We have a lot of great, powerful tools. But it's a sort of heterogeneous landscape, right? A bunch of different specialized systems spanning a number of different areas. So we have high performance computing, but we also have cloud systems and high throughput computing systems. We have systems that are specialized for doing data visualization, of course, large scale data storage, and then various experimental architectures. And so just kind of looking at the landscape, it feels a little overwhelming, right? It's overwhelming for even someone who specializes in cyber infrastructure and has a background in computer science, much less someone who is a domain scientist, in biology or astronomy or computational chemistry, to kind of get their head around all of this, we see as a lot of work. Here is just a quick glimpse of a bunch of different systems that we have just at TAC. And here you can see, really a suite of systems that span the various, capabilities and computing paradigms and so forth that I mentioned on the previous slide, right? And so again, just at our own center here, just at TAC, this is really a lot to kind of master. And when you then add to that the fact that a lot of computational research is increasingly distributed, it just adds a number of challenges, right? So increasingly, we're seeing researchers who want to or who need to work what we call the computing continuum. Right. So not just, having everything in the data center, but working across a continuum that really begins with IoT devices, instruments, sensors. These are things like DNA sequencers, large telescopes, shake tables, lasers, wind tunnels, things like that, right? So there's this whole step that is just getting at raw data that is on these remote devices, and then doing some kind of initial processing of that data. So at a minimum, one has to at least do some kind of basic quality assurance, right? Did I get all of the bytes that I had on the instrument over to the data center when I moved it? But also other kinds of QA analysis, ETL, right? Extract, transform, load scripts to take the raw data and process it into some kind of schema. And of course, already as part of this QA, ETL, and data pre-processing step, people are deploying machine learning. And so increasingly that data pre-processing component is getting sophisticated, more and more sophisticated. Once we've done pre-processing, traditionally we would pass to some kind of model simulation code. And again, traditionally this has been done with OpenMP and MPI. This is the kinds of bread and butter HPC stuff that we all or that we at TAC anyway have worked with for a long time, decades. But increasingly it is also machine learning, right? Training models, retraining, fine-tuning models, and that involves new kinds of technologies like CUDA and various machine learning libraries, PyTorch, TensorFlow. In any case, once you've finally done the simulation or computation, whatever it is, you tend to then want to disseminate your results. And that's where sharing and publishing comes in, right? So once you have obtained a result, you would like to disseminate that to the community, make it so that other folks can maybe get at your data, reproduce your computations. And so this is just the entire research computing life cycle that we see, and each step presents its own set of challenges, and requires its own kind of cyber infrastructure. So again, what we see, as we look across this, is a lot of challenges, and the goal with Tapis really is to at least help you sort of in tackling all of that different cyber infrastructure, all that different complexity. So at a very high level, Tapis is this web-based computing framework to support computational research in any research domain. It is domain agnostic. We have lots of different, projects and researchers using Tapis to essentially leverage this vast and heterogeneous cyber infrastructure in your research. To be a little bit more technically precise, Tapis is a set of hosted APIs, application programming interfaces, designed in a RESTful style, if you know what that means, a RESTful architecture style. So HTTP, URLs, nouns, and verbs for the most part. Together with this kind of large ecosystem of tooling, which includes software development kits in different programming languages like Python, JavaScript, and Java. We also have an official command line interface. And the main, if I could sum it up in two phrases, the main goals of Tapis are to allow you to manage data and execute code. Okay, manage data and execute code. Those are the two primary functions that we're really striving to achieve with Tapis. But of course, that managing data and executing code comes in a bunch of different flavors, depending on which phase of that research computing lifecycle you're in, and which cyber infrastructure you're interacting with. So high performance computing, cloud systems, high throughput computing, and IoT devices are all things we're trying to support in Tapis. These are sort of the three higher level objectives that we're trying to achieve or enable you to achieve with Tapis. So the first one is probably the most important: programmable interfaces to these advanced resources, right? We want to enable you to automate your interaction with all of these different kinds of cyber infrastructure. Right? So whether you're getting at data from an IoT device or a sensor, or trying to launch a function on our Kubernetes cluster, or trying to run a big HPC batch job, we want you to be able to use a single API, a single interface to orchestrate all of that, and that will enable it to be automated in a way that we find without Tapis, it would be difficult to do. And that automation also leads to the second objective, which is reproducibility, right? Whenever you do something in Tapis, the API remembers what you did, right? So if you submit a job to run an analysis on a batch scheduled system, Tapis is going to remember what input files you provided to that job. It's going to remember, environment variables, container runtime arguments, command line arguments, etc. It's going to remember all that and save it. And so when you come back 1 month or 6 months later, you have your output file that was produced, and you're like, oh, that was a really good result. What did I do to get it? You can ask Tapis, and Tapis will tell you what you did. And it'll give you basically one button that you can press to run it again in the exact same way. And I think Christian or Annika will maybe show that towards the end of the day-to-day. But yeah, reproducibility is a second goal. And then finally, this collaboration aspect, right? We know that research has this, for the most part, it follows this very particular life cycle where data and code starts out being private, right? While you're working out your research, while you're obtaining those initial results. But once you have results, you typically want to share things, right? You want to disseminate that information. And in between, there may be some times where you're sharing it individually with other collaborators. So we have this permission model in Tapis where you can, that allows you to achieve that. Basically, keep things private, share with individuals, or disseminate publicly, make it available, to any user in your community. And all of Tapis runs in the cloud. We're hosted at TAC. We host services at the University of Hawaii, at San Diego Supercomputer Center. So we have different teams and organizations deploying and running Tapis, but you don't have to deploy it and run it, most importantly, right? So this is something that you don't actually have to install. It's just running in the cloud. Yeah, so we've been fortunate enough to work with a lot of different groups and projects and partners over the 5+ years that we've been building Tapis. And at this point, we really do have a lot of collaborators. We have a bunch of science gateways that are being built with Tapis, but we also have institutes and centers and other kinds of organizations that are using Tapis in different ways. And so it really is, a mature, robust, production grade platform at this point. And so, yeah, we're proud of that. Okay, yeah, and this is just showing you kind of a quick glimpse of a few different science gateways. I mean, this is the Gateways Conference. I'm sure everyone is basically familiar with what a science gateway is, but in a sentence, it's a web portal, right? It's a web-based application that enables research computing for various domains, and so these are just some snapshots of some science gateways that are being built with Tapis, and it really is across a whole different spectrum of domains of science and engineering. Okay, so let me start to tell you a little bit of detail about what Tapis is, and you're going to learn, or we're going to talk about this, throughout the day, throughout the workshop today, but it's a complicated system, Tapis. I'm not going to try to tell you otherwise. So, it bears kind of introducing it in layers and sort of repeating. But let me begin. So it's sort of foundational to everything are what we call our 4 core services: systems, files, apps, and jobs. And these are the services that you're going to use when you are interacting with cloud and HPC systems for the most part. So, these will allow you to interact with data, as files and folders, directories on these systems, and execute code for the most part in an asynchronous, offline, like non-interactive manner, right? So I can tell Tapis launch this code on this system, it'll run it, and it'll tell me when it's done, basically. So those are kind of core services. But we have a bunch of other stuff in the platform, right? So one of the things that we do a lot of these days is data and metadata services. So managing large collections of database objects and document stores. We have a suite of services for doing streaming data uh, and um, and event management and sort of responding to events through the use of kind of functions that you write, kind of small bits of code that run. Of course, we have a big authentication suite, and it's essentially OAuth 2, if you're familiar with that, which we all are actually familiar with OAuth 2 and OpenID Connect. Even if you don't know those terms, it's the thing where you go to some website and it says log in, using your whatever account, and it bounces you over there, and then it bounces you back. So we do all of that in Tapis. And then we have this sort of burgeoning suite of machine learning services for doing, specific things, tasks specific to machine learning. And that's our pods, workflows, and ML Hub services. And so this gives you the ability to find models, discover machine learning models and data sets, to develop ETL workflows, to transform data that might be sort of raw into data sets that are ready to be used for training models, and for building knowledge graphs through ontologies and other kinds of things. And so I mentioned this AI Institute that we're involved in, ICICLE, which stands for Intelligent Cyber Infrastructure with Computational Learning in the Environment. We're really proud and happy to be involved with ICICLE. It was one of 11 institutes that was funded in 2021. Since then, there have been, I think, at least another 10 institutes. It's in the low 20s of institutes that NSF has now funded. But this is the one institute, the only one that is focused on cyber infrastructure. This is led by the Ohio State University, but it's a very big project. There are more than 70 principal investigators, or investigators at least, and over 100 total participants when you include students, grad students, and postdocs. And ICICLE is building on the Tapis framework, right? So Tapis is the framework for ICICLE, and I won't go through this diagram, but we have a sort of full architecture for how ICICLE components are getting integrated into the Tapis stack. All right, let me then say a few words about these core 4 services, a few additional words. And again, we will be going in, doing hands-on exercises here in just a bit on this. But let's start with the system service. So here is how you tell Tapis the systems you want it to interact with, right? Storage and computing systems like Stampede 3 or Frontera. Cloud systems, maybe you have a VM, an EC2 instance running in AWS, or maybe you have a lab server. You can register that as a Tapis system. And once you've done that, you can then use the files endpoint to manage data automatically. So the file service gives you endpoints for doing things like uploading and downloading data, transforming data using standard commands like move and copy and rename, but also transfer. So it gives you this asynchronous, sort of reliable transfer facility for saying, copy this directory of data from system A to system B. Then we have the app service, and this is where you actually register the codes, the scientific research codes that you want Tapis to execute on these systems. And we support different ways of registering applications. The one we like the best is containers, and we support Docker and Singularity container definitions. But we can also just run a zip run our archive. So if you give us, or if you point us to a zip file which contains whatever assets you need, we can copy that, stage that to the computing system, unpack it, and execute a script or entry point in that archive. And that's what the job service does, right? So jobs is your instantiation or your invocation of particular applications on particular systems. And jobs doesn't just launch the application, but it actually manages an entire life cycle associated with executing that application. So it will stage the assets, including file inputs that might reside on other systems. So it'll do that as part of launching a job. It will, of course, schedule the job to run, and if it's a batch scheduled system, it can do things like inject scheduler directives to specify the nodes, the node count that need to be specified, or the total runtime that is needed. It'll interact with the scheduler. It will not just do that, it will monitor the job once it's been submitted. So it'll detect when it goes from queued to running, and from running to finished. And it'll all along the way, it'll capture metadata about what's happening, how long it took for the job to enter these different phases, and so forth. So those are the 4 core services in a nutshell. And again, we'll be saying more about that. But how do you use Tapis? Well, so again, Tapis is just this cloud-hosted API. And so really you can use any tool that you want that allows you to make HTTP requests. And so you can use curl, right? You can use the old-fashioned Unix command line tool curl, if you're familiar with that. And this is how a curl command would look. You say curl, you need to pass the authentication token, which goes as a header. And we'll talk about that more, of course, in detail. And then you pass the URL. And so here we're listing all of the apps associated, in the Tapis platform, so that this user, the user associated with this token, has access to. So that's one thing you can do. We think curl is a little painful, actually. And so if you really do like the command line interface, well, we have our official CLI, which we think kind of simplifies the syntax, makes it a little bit easier to work with over something like curl. But we also have these official software development kits in different programming languages. So for instance, TapisUI, which is available on the Python package index, is our Python SDK. And this gives you a nice sort of idiomatic Python interface. So here we're submitting a job to run the Sailfish application with a given input directory. And so anyway, you can use an official SDK. And then, of course, finally, web applications. So we have a number of gateways and portals. You may not even know it's using Tapis under the hood. But that's another way that people, of course, use Tapis a fair amount. Okay, and then I mentioned the V3 CLI. It's just a command line utility for interacting with APIs, with the Tapis APIs. It does provide a number of different capabilities that we see as sort of advantageous over just using something like curl. It has a manual and an interactive mode so that you can interactively find commands and subcommands. The shell is also convenient. We think there's support for managing authentication across different projects, what we call tenants and different profiles. So that's really nice, so that you're not having to remember tokens and pass them around. It's also extensible and easy to update. So as new versions of the APIs come out, you just update very easily your CLI installation, and then you have support for those new endpoints. Okay, and then finally, I want to mention the TapisUI project. This is something that we're really excited about. This is a sort of serverless web interface to Tapis, and I think we'll be showing it off a bit here today. But the idea is that you can run a version of a portal or a science gateway without running any servers, just deploying directly to something like GitHub Pages, and it gives you a lot of functionality. I'm not going to say all the APIs and endpoints are covered yet, but we've made a lot of progress on putting a lot of the functionality that is available through the Tapis APIs into this user interface. And so it's a great way to be able to just figure out what is Tapis, but also, of course, to use it and get your work done. It is a TypeScript-based library, or I should say, it is based on the Tapis TypeScript SDK language bindings, and then it's a full front-end application that is built on React. Yeah, various deployment options, but we also have an extensions architecture to TapisUI now, so that you can essentially add custom functionality for your project, and sort of easily customize what's available in your instance of TapisUI. Okay, and I think that is end of the slides, because we go on to NLP next. Yes. So let me stop there and see if there are any questions or comments. Okay. So yeah, if not, I will stop sharing and can hand it over to you, Annika.
Yeah, actually, our next presenter will be Gilbert. Gilbert, do you want to share your screen?
Yeah, say, hey everyone, how's it going? My name is Gilbert, and I'm going to be talking to you all today about basically Tapis authentication, a little bit about how that works, not too much, and then um, running you through the Tech Jupyter Hub that we offer. So the first thing we're going to want to do, everyone should go to this URL here. I'll send this in the chat. And you should have gotten an Excel sheet with your name and basically your username for the account. And when you go to log in, the username and the password are going to be the same. If anyone didn't get the Excel sheet, or their name isn't on the Excel sheet for whatever reason, if you could just reach out to Annika, please, and then she can get you situated with a username and password, that would be awesome. But while everyone goes on to here, I'll just explain a little bit about what this is. So there's software called Jupyter Hub, which basically allows you to give people the opportunity to run their own Jupyter Notebook servers, and they get access to our resources here at Tech. And so we have one for each of our different projects here at Tech. So for example, Design Safe will have its own Jupyter Hub. Tech has its own Jupyter Hub, and these are all configured on our end, and they can all get different, they're all set up differently. Username should be similar. Yeah, that's right. But yeah, and so we just host this here at Tech, and we can allow researchers and stuff to come on, and then once you are accessing Jupyter Hub, the most common file that you'll want to be using is a Python notebook, which basically just allows you to run Python in your web, and you can kind of get like the graphical outputs and stuff from Python in real time in your web. So it's a little bit nicer than maybe running it from just your local machine. Okay, I do see some people saying that their username and password are invalid. Just make sure that your password is the same as your username and not the VM password. If you try to use the VM password, that won't work.
Yeah,
And so,
do we
yeah,
want to show them like from the beginning screen how to log in? Maybe some of them have confusion on that.
yeah, sure. Yeah,
Okay.
so let me just move my Zoom stuff around. So this is where you'll land. You'll click sign in. And then here I'll just put Gateways 24 Training 1. You can just copy and paste this into your password. You'll click log in. All right, and so when we're connecting to Tapis, we have this idea of clients. And so the clients communicate to Tapis on behalf of you. So this client is called Training JHub. So this is a client that communicates with the training tenant of Tapis. And tenant is basically just a logical grouping, or like a project, you might say, which allows us to, so like for example, if we have like the design safe tenant, we'll have the tech tenant, we'll have the training tenant, and so these training accounts won't work in other tenants. So it allows us to separate users based on what projects they're in. And then, so we'll go ahead and connect, and my server's already started, but once you connect, it'll take a second for your server to start up, but it should be pretty quick. And if there's anyone who hasn't been able to get their server up and running yet, please let me know and we can wait a little bit. Yeah, if everyone is able to log in and see their server started, if we can get a thumbs up or something, or if there's anyone who can't, just let me know before we continue. Cool. I don't think anyone is having issues, but so I guess we'll keep going. Right, so this is your Jupyter lab, and each Jupyter lab allows us to pre-install different things for you. So for example, if you look at this notebook, the sentiment analysis Python notebook, you'll see the first cell in this notebook. Well, technically this is a cell, but the first actual code cell is this command to pip install TapisUI, which, as Joe mentioned, is our SDK for the Tapis, for Tapis. We don't have to do that because we have already pre-installed it in this environment, so we can go ahead and skip that. And then this will just be getting our training account information, and we'll be using this to log into Tapis. So if you want, you can just click play up here to launch that code cell. And in here, you'll put in the same Tapis username that we use to log into the Jupyter Hub. So we'll put in the gateways 24 training XX, whatever your number is. And your password is the same, so you don't have to enter that. It'll just use your username. And then if we move down to this code cell, we will be authenticating and initializing our Tapis v3 client. So the first thing we're going to do is import Tapis from TapisUI, and Tapis is basically, as it says, it is Tapis. So once we log into Tapis, we will be able to make all of the calls to Tapis and be able to use the different Tapis services. So we have this base URL, which is up here, which is just basically the tenant.tapis.io, and in our case, our tenant is training. So we can just run this, and you'll see that first we call client.getTokens. So this basically actually authenticates you to Tapis and generates a JWT for this session. And then right here where we do client.accessToken, all we're doing is printing out the access token to make sure that we are actually authenticated. So if you look at this access token, this is what we call a JWT, basically just stands for a JSON Web Token. And if you look down here, we can see the claims of the JWT. So this just has different information about like who you are, what tenant you're a part of, a couple other things, when it expires, for example, what grant type it is. So in Tapis, when you're trying to authenticate, we do have several different grant types. I don't think we go over these in today's tutorial, but there are a few of them, but the most common one I would say is password. I'm not 100% sure if that's true, but I think so. And that's just your basic username and password to log into Tapis. Each token lasts for 4 hours. So you see here, it expires at 21:41, which is 9 hours from now. And yeah, and so now you're authenticated to Tapis. And another thing that we always make sure we do whenever you make any calls to Tapis using your JWT is we always make sure you're authorized to make said call. So for example, there might be some calls that you have to take as, well, yeah, as like an admin user, for example. And if your username is not authorized to make such calls, then you won't be able to make the calls. And this also prevents you from making calls on behalf of someone else. So those are things that the JWT allows us to do. And yeah, I think unless there's any questions, that's pretty much it when it comes to Tapis authentication. I mean, there is more, but that's the general gist, and that should be enough to get you all going. If there's not any questions, then I think we can pass it on to Annika, and she will talk about creating Tapis systems.
Sure. Thanks, Gilbert. So I would like everybody to have like a couple of minutes for them to generate the token if they're not able to, because once they're able to generate the token, rest of the things will follow. So if there are still if anybody is not able to get a token, let us know. We can try to debug that. You can just raise your hand and ask. Okay, I'm not seeing any questions on the chat, so let me share my screen here. Okay, so let's talk a little bit about the system service that Joe mentioned. It's one of the core services of Tapis. So the first thing you all did was you were able to generate an authentication token. So now that you're authorized to make different calls to the different Tapis services, one of the first things that you would try to do here is you would find like which storage or compute resources you have access to. Like, is anything shared with you, or you would like to just create your own resources? So in Tapis, a storage or execution resource is referred to as a system. And as Joe alluded to in his talk, so the system can represent a server or a collection of servers that can be exposed through a single host name or an IP address. And it can be used, it has like many different usages. For example, you can use it for managing your data. So you can store and retrieve files on those systems. You can run jobs, which means that you can stage certain input files onto those systems, the Tapis systems. You can execute your jobs on those systems. And once you're done executing your job, you can also archive those results onto a remote storage system or a data storage system. And then you can easily share those results with your colleagues. So the experiments are like completely reproducible, because we are making a note of like storing the data and the output of the job at every stage. So this is in the hands-on part of the exercises, we're going to show you how to create a Tapis system, but I just want to give you an example of how a Tapis system looks like, the JSON. So at a very high level, every system would have an identification like a ID, which is supposed to be unique across a tenant. So basically, like once you create a Tapis v3 storage system in a particular tenant, you cannot use the same ID for something else. So that is something to remember, that every system ID has to be unique in a tenant. And then we support different types of systems. For example, there are Linux systems, S3 systems. We also support Globus and iRod systems. So these are the 4 types of systems that we currently support. Description is something which is a logical description for you to remember why you had created that system in the first place. And then who is the owner of the system. So this information typically comes from the JWT, like who is making a call to create a system. So the person the user who is making that call is usually the owner of that system and has elevated privileges on that system. But you can definitely share it with a single user or a group of users. You can also use a service account to create a system so it can be used by many people. And then, as we said, like host is basically, it can be like a IP address or a host name that you can identify your system with. And then there is a root directory, which is whenever you try to manage files on the system, it will always be relative to that root directory path. So we'll see some examples here. And can exec is basically whether can you use that system for execution or it's just a storage system. And then something important here is the effective user ID. So you can set the effective user ID to be static or it can be dynamic. Here we are assigning a static user. But when it is dynamic, depending on who is making a call to access that system, they can basically use that system, same system definition to, by adding their own credentials on the system. So it's always a good practice to have the dynamic effective user ID set up. So you can share, many people can use that same system definition by adding their own credentials on the system. And then there are many authentication methods that we support. So PKI keys is obviously like one of the most standard one that we recommend. But for today, I think we're going to use the password authentication method because it's for its simplicity. But PKI keys is there, and then access token is there for S3 systems and so on. So this is like a very simple definition. Once you create a system, there are certain attributes that you cannot change. ID and root directory are the ones that you cannot change. But other than that, most of the parameters here, you can patch the system definition. If something changes in the future, let's say the host changes from Stampede 3 to Frontera, you can update that same system definition to have a different host. So that flexibility allows you to have the same system definition, but change it with the time or requirement. So let's go back to our notebook here and try to create a system. So first important thing that we want all of you to do is to change this host IP to 129. There was a typo here, so which didn't get reflected in the latest image. So please make sure you change this, otherwise the create credential call will fail. Also, if there are any questions on the Zoom chat, I don't see it, but somebody please try to just unmute yourself and ask. I think there are a few questions. Yeah, change the IP address to 129. Thanks, Christian. And then now here, if you see, like we are creating a system ID, which will have an ID as gateways 24 virtual machine because we are using a virtual machine for this. And we have a user ID, which will be your training account name. So the description here is just like a test system, and it's a Linux type of system. And the host is going to be this IP address that we have hard coded here. So effective user ID is dynamic, which will be resolved at the runtime depending on who is the caller who is making call to create a system. And the default authentication method that we're using here is password. So, and as you can see here, we have set the can exec to be true. So we're going to use that same system for running jobs later. And also there are some job runtime parameters that we see, which is like runtime Docker and the job working directory, which is basically like where the job is going to run from. So the call to systems API to create system and bypassing all this definition should give us a URL of the new system that has been created. Okay, maybe I have it created already. That's why it failed. So maybe I just called it. I just appended my ID here. So basically now the ID is different because otherwise that ID already existed and it didn't let me create. So every time the ID has to be unique in a tenant. So now it has created the system. Is everyone able to create a system? Are there any questions on the chat? Okay, if it is successful, you should see a URL that has your system ID appended to it. And now let's say if we have to change the description of the system, because description is something that we can change. So let's try to use a patch system call to change it. So that was successful. I'll show you how we can see the details of the system, but just for your information, the call to get systems should return you all the systems that you have access to or somebody has shared with you. So I was testing with this account earlier. That's why I have like three or four systems here, but you should see just one for now. And this is a brief summary of every system that I have access to, which gives me like who's the effective user ID, what host the system is created on, whether it has a parent system, and what type of system it is. So this is a very short summary about every system. But if you want to know the details, like there are a lot more parameters that you can see when you get a detail of a particular system. You should see this big JSON that's returned to you. So it basically tells you everything about the system, which you can use, programmatically to access information from. So here we see that is public is false because we haven't really shared this system publicly across the tenant. Right now it says is public is false, but you can share it with a group of users. Okay. Are there any questions on the chat?
Yeah, Annika, Mona has a question about the parent ID field.
Yeah. So basically, if you look here, you have to set your system to allow children, and I think once you set it as true, then you can basically create the child systems from it, which will have access to the different files and other things that are on the system.
Yeah, that's exactly right. So if you essentially if you have a situation where you want a bunch of different systems to be defined and share a common set of information across them, you can define that common information once in the parent system, and then you can sort of inherit that in all of the children, and it can help you sort of with duplication of configuration across the different system objects.
Yeah.
Does that answer your question, Mona?
Yes, it does. Thank you.
Mm-hmm. Yeah. Thanks, Joe.
Yeah, and then there's another one from Anna. So can you restrict users from creating new systems? This is a really good question, actually. So actually, you can't right now. Not super easily. Is the short answer. The slightly longer answer is that it would be technically possible with a little bit of effort, but there's not a simple API call that you can do to just to turn that off. But basically, it would need to be something that we enabled for your project, and we would use a tenant within that. That's our concept of kind of logical isolation, right? That Gilbert mentioned. So we would create a new tenant for your project. We would make you an administrator in that, and then we would find a way to essentially allow authentication, but not allow users. Some users or whichever users shouldn't be able to create systems, not allow them to do that. It's technically possible, but it would take a fair amount of setup and coordination with the core Tapis team, if that makes sense.
Yeah.
And then Richard is asking if we should log into Tapis using what's in the spreadsheet. Yes. So okay. So one thing, Richard, to know is that the spreadsheet has username and it has VM password. But for logging into Tapis itself, the password is the username. So the Tapis username and the Tapis password are the same, and the VM password is used in the notebook to create the Tapis VM system. So I guess if you could confirm that you're actually using the Tapis username as the password and see if that works. Okay.
Yeah, sorry
that
about
works.
the confusion,
Great.
everybody. I think
Yeah, we'll have an extra column next time in the spreadsheet to make that more clear.
Yeah. Okay. Thank you,
Okay,
Joe.
and
Any
then
other
another
question?
follow-up.
Yeah.
Yeah, as another follow-up, users can create a system out of their own machines. Is that right? Yes, that is true. And then this is still secure since Tapis is an API for interacting with them, and all the machines will still be isolated. Yeah, so this is a great question. So it is still secure. So there are a couple of pieces to this. First off is that when you register a Tapis system, actually all you're really doing, or all you really have to do, is provide sort of the connectivity information, the protocols, you know, the domain, the fully qualified domain name or IP address, the protocols that the system speaks, right? Essentially publicly available information. You're telling Tapis, hey, you know, here is a host, and here is the way that one interacts with it. So that's sort of publicly available information, or it maybe not, like, you know, maybe you consider that to not be publicly available, but the point is that that information is not enough in its own for Tapis to actually start communicating with it, right? In addition to that information, Tapis also needs a credential. It needs some kind of access mechanism. And so this is where, you know, we can do usernames and passwords. We can do PKI keys, SSH keys. You know, we can do API keys, tokens, depending on the system's authentication protocol. So that credential piece can be added, you know, can and is typically added separate from the just informational, this is how you communicate with the system. So that's the first thing. The second thing is the system definition and the credential start out as private to the individual who registered them. Okay, and we never share credentials. Actually, you know, we don't even give you an endpoint for getting at the credential once it's been saved with Tapis. So unless you explicitly grant another user access to that system, or grant another user access to that credential, they won't have access to the system, even once Tapis, you know, has the ability to interact with the system on your behalf. And so that's the extent to which it's sort of isolated. Does that answer your question? Or does that make sense?
Yeah, it answers my question and more. Thank you very much.
Okay, great.
Awesome. Thank you, Joe. I think it's a great segue to our next call, which is basically the same, like creating the user credentials. So far we have created the system, but it is of no use to us right now because we don't know a way to access it. Like Tapis doesn't know a way to access it. So what we would do is like we would explicitly create a mapping for the Tapis user ID along with the user that is present on that virtual machine. In this case, we have the username that we have created on the virtual machine and the Tapis username is same. So we don't provide it with a login username. Otherwise, there will be like another, if they are different, there has to be a different thing here, like another extra parameter, which is a login user. And that's the real user with which you would, you know, SSH as on that virtual machine. So basically like create user credential here. We are providing it with the system ID that we want to create credential on, the user ID and password. If it would have been the PKI keys, we would have given it the private key and public key or access token in the other case. So let's try to create a credential. And once you create the credential, then Tapis knows like, you know, how to access files or, you know, run jobs on that system. So let's try to do that. And when this with this call, it basically also tries to check if the credentials are correct. So if there are incorrect credentials that are provided, this call wouldn't succeed. So that's like a checking point for you to make sure that you have provided right credentials. So once everybody is able to create credentials, we can proceed with the next step. I'll just wait a couple of minutes if anybody has questions doing this. guess we can proceed. So the next thing that we're trying to do is use the files service. So as Joe mentioned in his talk, like file service is also one of the core Tapis services. And it has many, with file service, you can do many operations. You can do list files, upload files, move, copy. You can also do Linux operations like make dir. You can use like chown, mod, all those things. So let's try to list the files by providing it a path, and this path will be relative to what you have set in the root directory. So every time you want to list a file, you have to provide a specific path that is relative to the root directory. I guess there is a question. I'll try to see in the chat. Okay.
Yeah, so it looks like there's a problem in the chat.
And the credential.
Registering the credential.
Okay.
It looks like that's the incorrect IP address.
Yeah.
I'm writing it
yeah.
in chat.
Okay. So those who joined late, I think apologies for this. We have a correction here in the host IP address. There must be like 125. Can you change it to 129? So that should work for you.
Okay, got it.
Yeah, but I think you would have to do one more thing because you have already created this system. You would have to patch that system definition. So maybe in the patch system, you can add the host to it in this JSON here and then try to patch it. Otherwise, it would not reflect in the system definition. So just try to patch with that IP address. And if you want to check whether you all have correct IP address, maybe this call is where, which gives you the system details, will tell you what host is recorded for your system. So if it is 125, try to patch it up and see again if it got the new one. And then your create credential call should pass. So as I mentioned that there are a bunch of these file operations. If it lets me, see, if you just hit a tab here, you will see that there are these different file operations that you have, like create, transfer, delete permissions, get contents of the file, and all these things here. Insert, list files, make dir, move, copy. So you can explore all these options. And I think in our like read the docs here, let me see if I have a link for read the docs. Can someone drop a link to read the docs in the chat?
Yeah, I'll put it, Annika.
Thank you so much, Joe. So that is like different operations that you can do with file service or with any other service, for example, and explains you in great detail. So you can try that. Okay, I guess, do people need like a quick break at this point, or should we proceed with the NLP?
We have a question about the languages used in
Okay.
Tapis and also whether it is open source.
I can take that. It is open source. And the languages that are used are primarily, I assume this means the languages that are used to implement the Tapis services. They're primarily Java and Python. We have a few things written in Rust as well.
Thank you, Joe. I guess it's okay for us to proceed. So, Joe, do you want to do the NLP slides?
Sure. Let
See
me
the-
let me throw just really fast. I threw a link to our project page in GitHub for Tapis, and there you can see all the repos. I think there's like over 100 repos now, which is kind of crazy. But yeah, there are 110 repositories. Wow. But yeah, you can see the license information and all of that. Yeah, and once a system is created without a credential, nobody can execute on that machine. Exactly. Yes, Tapis can't do anything without a credential. So yes, absolutely. All right, so we'll move on to natural language processing. Is that what we want to do? Okay,
Yeah,
let me
thank you.
go back to sharing. Okay, is it coming through the slides?
Yeah, we can see that.
Okay, great. Yeah, so we want to talk a little bit about natural language processing, NLP. And we really want to talk about the transformer architecture that has really been taking the world by storm over the last few years. So we're going to introduce that in a minute, but it's worth pointing out, right, that the transformer architecture really was invented to deal with NLP tasks, actually specifically language translation. So that is translating text from like English to Russian or one language to another. So we thought we'd give a background on NLP, and then before we move into the transformer architecture. So yeah, so really at a high level, NLP focuses on tasks that involve understanding natural language. It's definitely one of the oldest areas of AI, dating back at least to the 1950s. And so here are just we've listed some common natural language processing tasks, NLP tasks. So sentiment analysis, right? We want to understand the sentiment expressed in a text. Is it a positive sentiment or is it a negative sentiment, right? If you have a movie review or you have a tweet about a product on X, is the person conveying something positive about the product or the movie, or are they conveying something negative? Text classification is another example of NLP where very similar to sentiment analysis, but where you're basically trying to classify text in different ways. So it's a sort of sentiment analysis is sort of a special case where you're classifying it into typically binary, positive or negative, and text classification generalizes that to maybe parts of speech. Is this a noun? A verb, an adjective, or topic? Is this a paper about biology or about computer science or mathematics? Of course, language translation, which again is the specific task that transformers were invented for. But that's again just translating from Spanish to English or French to German and so forth. Text generation, this is like autocomplete, right? Fill in the blank, etc. Various kind of tasks related to generating text in some context. And then, of course, question and answer, right? So given some question, we want to not only understand the meaning of the question, but be able to provide an answer to it. So that's just natural language processing sort of in a nutshell. In 2017, though, a group of researchers at Google introduced this new deep neural network architecture called Transformer. And it was done in this paper, Attention is All You Need. And really, like I say, the focus of this paper was on language translation. So NLP, but specifically translating between two different languages. And in some sense, we want to try to give you a flavor for this architecture because it is proving to be so instrumental, so pivotal. So in some ways, you can really think of the transformer architecture as an attempt to address challenges or shortcomings in what was at that time in 2017 the current sort of state-of-the-art models, right? And these, if you do know any machine learning, these were these models called recurrent neural networks, or RNNs. And to overly kind of simplify a little bit, these limitations were broadly twofold, right? One, RNNs have a limitation in terms of the input length. So if you have a text as an input that is quite long, right? Think a whole paper, multiple pages of a paper, or a novel even. Then there are these so-called memory issues in RNNs, right? Remembering what came first versus what came later in that input text was a challenge, and it basically prevented the models from understanding sort of sufficiently large input texts. A related issue had to do with performance, essentially slowness of the RNNs due to a lack of parallelism. So RNNs took the approach that the input data was a sequence, right? And you can think of that as very natural, right? A sequence of words, for instance. But the RNN processed that sequence essentially one token at a time, one word at a time. And therefore for long, very long input sequences in particular, there was this issue, there was this performance issue. So this paper introduced this new notion called attention, and that was really broadly to address these shortcomings. Yeah, and as this slide says here, transformers may not fix all of your natural language problems, but they are a very it is a very valuable idea, and it is having some big impact. So we want to kind of try to actually break down the architecture a little bit, or at least give you sort of a glimpse of what's going on here. And so this slide actually depicts the architecture diagram that's in the original paper. So if you go to Attention is All You Need, you will actually see this diagram. And what you'll notice, actually, if you look at this, is that there are really two primary components, a left half and a right half. The left half is the decoder. The right half is the left half is the encoder, and the right half is the decoder. And these two components are almost identical, with the exception that over here we have a masked multi-head attention component that we don't see over here. And so so if we they're not lined up, but these two components over here are exactly the same as these two over here. And so in a nutshell, we kind of have two components that are very similar to each other. And so we're going to focus on the left side. And so if we just focus on this left side, we'll see that essentially there are three primary components here: a language embedding, the attention component, which is labeled here, a multi-head attention, and then this feed-forward neural network. And so so really, what we want to do is try to understand these components, and in order to understand them, it's helpful to actually look at the original task, right? Again, language translation. So in the case of language translation, and in general with machine learning, right, we'll have a labeled data set. We'll have a set of text fragments or sentences in one language, and an associated translation of that fragment or text in another language. And so in that context, what you're going to have is that the input text is going to flow through the left-hand side. So if I'm going from English to Spanish, I'm going to have English text flowing through the left-hand side, and I'm going to have the corresponding translation, say Spanish, flowing through the right-hand side. Okay, and And this is happening simultaneously. That's a key point. These are flowing through the architecture simultaneously. Now, one component that is not actually depicted here, it's not actually depicted in the original paper, but that is the tokenizer. And the tokenizer is essentially responsible for taking the raw string, whatever sentence in English that I'm trying to translate, and converting it into a set of tokens that can be passed to this language embedding, this input embedding component here. And again, a key point here is that the entire sequence, as well as its translation, are passed all at once. And so that's a major difference from the RNN. And it's the thing that really allows the transformer to achieve much better performance. Okay, so let's talk about the tokenizer and the language embedding, and then the attention component in turn. So the tokenizer, again, is really the way in which virtually all NLP networks work, because neural networks in general cannot work directly on text data, right? The text data has to be converted to some kind of numeric data, and that process is called tokenization. So these are like simple rules for mapping words or word fragments, as is sort of the standard now, to essentially what you can think of as an array of integers, right? Integer IDs, also called token IDs. And once you have those token IDs, they're passed to the language embedding. Why are we doing this? Well, the token IDs typically live in some really high dimensional space. Right? There are a lot of different token IDs. If you imagine, a token for every word, which is not quite right, but if you imagine a token for every word, there's tens of thousands of token IDs. So you're talking like a tens of thousands of dimensional space. And so what we want to do is we want to learn an embedding that essentially maps that high dimensional space to something much lower dimensional. Okay, so it takes your big token IDs and it maps it down into a much lower dimensional space, but one that hopefully preserves features of the language, right? Preserves features like similarity between words. Okay, so that's the tokenizer, and then the language embedding, and then finally we have this attention module. And again, this was sort of the new piece to transformer. So it's hard to really describe the attention module in a lot of details abstractly, but let's think of an example. I think to illustrate this, that's probably the easiest way to work. So so if we consider this following example, I went to the park with my dog and threw the ball. It went high in the air. The it here is a pronoun, right? And we know that in this case, the it refers to the ball, okay? But if we take a second version of that and we change the second sentence just slightly, and we say, I went to the park with my dog and threw the ball. It barked loudly. Now the it refers to my dog, right? And so this is very common, right? With pronouns in general, they tend to refer to concepts, nouns that were introduced prior. And so, of course, in order to understand the meaning of the sentence, we have to understand what those pronouns refer to. So this is critical. And the idea with attention is there are some key words that might have come before or after the word in question that are essential for us to understand the meaning of that particular word, right? And of course, in the first case, we know that the keywords are dog and ball and high in the air, right? Those are the keywords that we need to pay attention to, if you will, to know how to resolve it, to know what the meaning of it is. And if we move to the second sentence, here again, it's dog from the first sentence, but barked loudly. So it's that combination of words, again, some before and some some occurring before, some occurring after the word in question, it, that allow us to resolve the meaning of the word. And so that's the idea of attention, in a course, nutshell. It's to say that in order to understand certain meanings, the meaning of certain words, we need to pay attention to certain other specific components of the input. Not all components, just specific ones. And the final, of course, component is the feed-forward network. This is a sort of standard thing, right? This is something that NLP folks have been doing for years, but it's worth pointing out that the feed-forward network is actually the biggest component of a transformer architecture. So in some sense, the attention part, while novel, is a smaller component of the overall architecture. Okay, and then the last thing just to mention here, so I mentioned that on the right-hand side, we have this added masked multi-head attention. So why do we have this masked component here on the right and not showing on the left? Well, so the idea is, again, going back to our language translation task, we have, let's say we have English input and we have Spanish that we're trying to translate. So English is flowing into the network on the left, Spanish on the right. The idea with masked attention is that we're going to hide some of the input, some of the attention matrix specifically associated with some of the input sequence. Okay, and the idea is that in particular in the case of translation, we don't want to know the whole attention associated with the translated sentence. We only want to see the piece that has been translated so far, right? I mean, that would be only fair. We only want to show the attention for the part that we've already translated. And so we're going to hide some of the attention, from the network. And so for language translation, we have these two components. But it's worth pointing out that some tasks don't need this masking, right? So for instance, if we're just doing sentiment analysis, if we just want to say, was this a positive movie review or a negative movie review? We want to let the model see the entire sequence. There's no need to mask, and we can utilize the entire attention matrix. So in that case, we can actually use encoder only models, right? And those do exist. So we have encoder only models that just include the left side. And conversely, there are tasks, for instance, sentence completion, where we don't have two parts, and we want to always be masking some part of the label. And so we also have decoder only models where we just have the right half of the architecture. So, okay, I think that concludes us. Yeah, this is just some links for the end if you want more information. But are there any questions? I know that was really high level and hand wavy, but are there any high level questions about transformers that we can try to answer? Okay, well, if not, I can stop sharing. And do we want to take a break, or do we want to, Annika, do you want to do your sentiment analysis?
We can show them how to use the transformers library quickly, and then we can move on to the Tapis applications part then.
Cool.
Yeah, thank you. I hope my screen is showing up here. So basically, whatever Joe mentioned about transformers, we have a very small example to show you from the transformers library from Hugging Face. So if we execute this cell here, we import the pipelines from transformers. And here to the pipeline, so you can submit different types of tasks. For example, in this example here, we are showing the sentiment analysis task. It takes a little bit to download that model. And once it's there, you can basically change that text and see what is the sentiment of that text that we have provided. So it gives you a score for the sentiment. It also gives you a label. So it's a positive sentence with score of 99. You can try changing it and see if the results vary. But this is a very simple application. In the next part of this tutorial, what we're going to show you is like how we convert this sentiment analysis task into a Tapis application and run it on the Tapis systems through the jobs API. So I think at this point, maybe we can take a quick break for like 10 minutes or so and then come back and try to understand more about the Tapis apps. Hello, welcome back everyone. So let's get started with the next part of this tutorial. So for us to run any Tapis job, the first thing that we have to do is to create a Tapis application. And what exactly is a Tapis application? So basically it's a versioned and a containerized executable that we can run on any execution system that has been registered through Tapis. And it contains all the information that is required to run a job. For example, let's say you need to stage a certain input files before for launching your application. So the Tapis applications will have information about that, how to launch your application, how to monitor the application during execution, and how to archive the output. So all this information can go in the that is required by the Tapis jobs will be contained in the Tapis applications. So just like we saw an example of the system JSON, we have an example of the application JSON. This is a very simplified version. We'll see when we create the application, I'll show you how we have created the sentiment analysis application from that. So here the ID is again that is specific to your application and which helps you to identify what application it is. And then every application has a version. So you can go on incrementally increasing the versions of the application as and when the changes are required. But the combination of ID and version has to be unique across a tenant. So you cannot create the same app with same version over and over again. It has to be different version. Then description is something like a logical description that relates to your application, like a test application, sample application, or sentiment analysis application, whatever. And what runtimes are required for an application to run. So currently we're supporting like Docker, Singularity, and also there is a zip runtime, as Joe mentioned earlier. And container image is basically like a reference to your Docker image, for example, from where it will get the executable containerized executable to run it on the execution system. And then there are a bunch of job attributes that you can specify in your application, like what execution system ID your application is supposed to run on. So these are some of the job attributes. They are optional and you can also overwrite it in the job definition, and we'll see exactly how to do that. So let's get back to our notebook here and try to look at the application definition. So the name of our application here, or the ID that you have here, is like Gateways 24 Sentiment Analysis along with the user ID. And this is the version 0.1 with a description. So the job type that this application is going to run a fork job. You can also, for HPC like systems, you can specify batch type as the job, which is able to run like a batch scheduler, and we are going to see that also. And the runtime supported is here Docker with the container image that is already on the Docker Hub with this tag. And the archive filter helps you identify which files to include or exclude during archiving. So you can restrict your archiving to a certain set of files. This can be set as true or false depending on which files you want to include or exclude. How much memory is allocated to run that application, how many node counts do you need, how many cores per node you need, and how much time you want that application to run for. So all these parameters are necessary. I mean, I wouldn't say they're necessary, but they provide a good amount of information for running your job. So you can set them prior to running your job. So let's try to create this application by using the apps service. So basically like client.apps.create version, and we are providing this application definition. So we should again get a URL which shows you that this is the application, and we want to get the details about the application. We can give a call to get apps latest version. So this gives you a bunch of information about that application, which you can take a look. Again, on our reader docs, you would find detailed information about what each attribute is. And as we share the systems, we can also share applications. Here you see that shared with users, you can provide usernames that you share your application with. So is everyone able to register application? Any questions here before we move on to the job part? I'll just wait a couple of minutes to see if there are any questions on chat. Okay, I guess we can move on to the jobs. So basically, once you have a system registered, you have an application, now you are all set to run your job, Tapis job. So basically you can launch those applications directly on the host, or you can run them through some schedulers like Slurm. We are going to show you that example. So two container runtimes are currently supported, Docker, Singularity, and we also have Zip. So the job service in turn uses all these services to run the job. We have seen the systems, apps, files, and security kernel is basically like a vault, a place where we store our secrets for authentication, credentials, and stuff. And once you submit a job, it goes to different states. So let's say when you submit the job first, it enters into a pending state. Then it looks for the inputs to process, like what all inputs it needs to run. It stages those inputs on the execution system, and any other runtime assets that it needs, it changes to that. And then finally it submits the job to the execution system where it is queued, and once the resources are available, it starts running. So once the running is complete, depending on whether you provide archiving, as you want to archive it to a remote system or you archive to the same system, it will start archiving. And finally it enters into finish state if nothing goes wrong here. But let's say, for example, there is an application error, or the resources are not available, or if the user cancels the job, it can enter into these states like blocked, canceled, and failed. So in the job message, you would see like what is the last message that your application provided, and how you can view the job output. We're going to see that in a little bit. So to show you an example of how we were able to build this application, I just want to, for you to build similar applications, you can find it on our GitHub repo here. So if you go to our GitHub repo directly from the tutorial page, you can see Docker build multiple sentences, and there is a Docker file from Hugging Face transformers. From Hugging Face, we are getting the transformers, and then we have this sentiment analysis.py file where we're basically doing the same thing. Like from transformers, we're importing pipeline, and basically like to the transformers pipeline, we are passing the sentiment analysis task, and then we are storing that output results into the Tapis output file. So this is just for your knowledge, so that if you want to convert this application into using some different task, you can easily do that. And once you have this, you can containerize it and store it on the Docker Hub. And when you're registering that application, you can provide your own container image. So if you want to try out some other tasks, you can definitely do that. So once you have that information, now we're ready to submit the job. And for submitting the job, it's very straightforward. You need the name, a logical name to identify that job, description. Application ID is like which application you want to run and what application version you want to run and on which system you want to run that application on. So you can specify this during job submission time. It can be any application, it can be any Tapis system that you have access to. It doesn't have to be like, any one particular system. You can run your application on any Tapis system that you basically have access to. And in here, we are also providing the parameters, which are the application arguments. So just like we saw an example where we were providing a single sentence, here our application can really take in multiple sentences because of the way it's programmed to do so. So you can try to submit your first job here. And once it runs, it gives you a job response, which is again like a very detailed explanation of where the job is going to run, where it's going to archive, and all the other details. So all this information will help you identify like what is your archive system directory, what is your exec system directory. And again, each and every parameter is explained in the reader docs in case you want to take a closer look at. And I think the one important thing here is basically to check the status of the job. So when you first submit the job, as I mentioned in the slides, it goes into the pending state, and from there it takes its goes to next state. And there's also like a last message thing that we'll see here. So here you see the status as pending, but now it is already advanced because we're not continuously polling it. So let's try to see the current status of our job. It might have advanced to different state, and it was a quick one, so it finished very quickly. But if you want to try to submit another job, for example, like the same job again, you can do that. And here, let's try to see if we can get a different state this time. So now you see it's staging. It will advance to a different state, which is like running. And I think it's very close to completion. So it's still running. And now you see that it's finished and it was like normally completed. Now, what if you want to see like what were the output of the job? You can directly give the output path to download for with the job ID, and it will give you that. This is a little different way the sentiment analysis app was written, because it classifies it into different emotions among these, like anger, disgust, fear, joy. And depending on what sentences you provided here in the app arguments, this is great. This is not fun. So we have one positive and one negative sentence. So you can see that all the negative emotions, it is tried to give a lower score, and for a positive sentiment, it has tried to give a higher score. Similarly, for this one, it tries to give a lower score for positive sentiment and a higher score for a negative sentiment, like sadness is the highest. So you can try changing those two texts and play with it a little bit. Any questions on running the application? Sorry, I haven't been checking chat here. Okay.
I actually have a couple of questions. May I ask them?
Sure, yeah, please go ahead.
So what I was gathering from the job response, I believe it was called, is that each job will be living in its own directory. So if I run a job multiple times, I won't be overwriting any output.
No, you won't be, because every job is given this, you see this UUID. So basically, this is a unique identifier for the job. So every time you run a job, you would get a different identifier. So it will try to have all the outputs and all the input files in. It will try to store it in this directory, which is corresponding to the UUID of the job.
Great,
So
thank you. And my second question is, so we're all running this on the same host, is that correct? Because we all use the same IP.
right.
If this was a more computationally intensive task and we all ran this, there is no safeguarding against overloading the system. We just have to be wary about that ourselves. Is that also true?
Not a 100%. So first of all, you all are running on the same virtual machine, but you all are under different user IDs. And regarding the load, we have many job workers that have been currently assigned for this particular tenant. So they would all run, make sure that it's well load balanced and it wouldn't crash, or there are no race conditions that are happening. So, but
Yeah, and also if I could, Annika, because I think the question may have been more about overloading the actual compute resource itself, which is definitely, so there's overloading Tapis, the middleware layer, but then, if Tapis manages to run 5,000 jobs or start 5,000 jobs on the VM, or even 2 jobs like the speaker mentioned, that were more computationally intensive, then the host itself could be overwhelmed. Tapis does have support for setting quotas on the execution system. And so those quotas can take different forms, but for instance, you can say a maximum of so many, running jobs total, or a maximum of so many running jobs per user. And so you can set those bounds up when you're defining the system, and then Tapis will enforce them. And so you can essentially use Tapis itself as a kind of a queue. And so that if 100 jobs get submitted to Tapis, but there's a quota in place for that physical system, Tapis won't actually start them right away, if that makes sense.
Yes, that makes perfect sense. Thank you both.
yeah, thank you. Thank you,
Sure.
Joe. Yeah, I was just trying to see if there is, I mean, I know there is a parameter which helps to, when you're registering the application, you can basically have a limit on how many users can run that application on a current VM. So I was just trying to look at our read docs. I think that will give you more information on max jobs per user. So when you set this to a certain number, I think that will help you limit how many users, maximum number of jobs can be submitted by that user.
Yeah, max jobs per user, and also max jobs above
Max
that.
job,
And it's
yeah.
an excellent point you're bringing, Annika, that this can, I said it could be set at the system level. It can also be set at the application level.
Yeah.
So you have a fair amount of controls there. Yeah, it's a very good point.
Yeah, I mean,
If I do,
sure, go ahead.
I have a quick follow-up on that max job per user or the max job. If it exceeds it, does it just rejects it outright, or does it just queue it up in the system?
It queues it within Tapis.
Okay.
So it doesn't reject it, but it will put it within our our internal queue. So
Okay.
even if the system doesn't have a queue itself on it, you'll still be able to kind of throttle.
Okay, thanks.
Yeah. By the way, all these questions are really great. Thanks for bringing them up and trying to understand it. So thanks for asking those questions. Okay, I think if everyone is everyone able to run their jobs and try to get it to completion? Any questions there before we move on to the next part? I guess not. Okay. So the next part is a little bit of repetition from what we have done so far, but the only difference is like now we're trying to run it on a HPC like system. So let's say if you want to run it on Stampede 3 or I guess is there a question? Joe, do you want to take this question?
Sorry, Annika. Oh, I see. In the chat, max jobs doc seems to indicate max queued jobs. That's right. Beyond that, jobs will be rejected. Yeah, thanks, Amit, for that. Beyond that, jobs will be rejected. Let me double check and get back to you on that. I believe that's correct. But yeah, I will confirm.
Thank you. Okay, so next part that we are going to do is basically like create a HPC like system and try to run that same application along with the similar job that we have seen before. So here the difference in the execution system definition is basically like we have provided it with a batch scheduler like Slurm, and we also have a scheduler profile which loads the different modules on that system before it tries to run the job. And then the important part is like the batch logical queues. Now these queues refer to the actual queues that are on the HPC systems, but the name that's given here is the Tapis normal queue. It maps to the actual HPC queue name normal, and all these parameters are in a way set directly from how the system queues are set up. So with the queue info, you can take a look at that and then basically try to set up the queues for your execution system. Other than that, I think this is again like a Linux type of system, and I already mentioned that it can run batch is true, and since we're going to run an application on it, we have set the can exec to true here. So, and the job runtime, since it's a HPC system, we have specified it as singularity, and the job working directory is pretty much same. So let's try to create this system again. And if that creation was successful, it should give you a URL. And now when you try to list the systems, you should see at least two systems that you just created. One was a virtual machine-like system, and the other was a HPC-like system. And if you want to get the details on the HPC-like system, you can give a call to the get system with that system ID. And it should show you again the same set of parameters that we have set up. And now we have created the system. The next step would be to register the credentials for that system. So the call is pretty much same. As I mentioned, most of this is going to be just a repetition. And since the successful credential creation, after that we try to list the files, and it lists the files on which is relative to the root directory. Now once we have registered that system and we are able to access it, next step is to run an application, like create an application which can run on that system. So in the previous application, if you remember, the job type was fork, but here we are running Slurm, so it's a batch job, and the runtime is also different, singularity. And for our convenience, we did a singularity pull of the Docker image and stored it in a location where everybody can access that zip file, because it's a big file, and it's like in the best interest of time, it's easy for everybody to just use one zip file other than everybody downloading it and trying to use. But yeah. So again, the parameter like the archive filter is same. We specify here which files to include during launch, what memory requirements are there, node count, and all those things. So let's try to register that application. Okay, it already exists, so I might have created that before. So I'm going to try to change the name and try it again. Okay. Okay, almost successful. So it was just that application already existed, so it didn't allow me to register with the same name. As I mentioned, the ID and version should be different every time you register an application. Otherwise, that call wouldn't succeed. So now, when I list the applications, I can see that I have so many different applications that I can run. And again, get app latest version gives me all the details about that application, uh, containing all the different parameters that are used. And this is basically the same. The only difference here is like I have used my HPC application and I'm trying to run it on a HPC system. Other than that, everything should be same. If you try to look at your job response, it will show you first that it was in the pending state. And then later, when we try to get that application ID and check the status of the job, it says that it is queued. So let's try to poll it one more time to see if it advances. Yeah, it's now running. It's a small application, so it shouldn't take that long to run unless there's something wrong. So yeah, it's finished now. And the output file again is the outputs are stored in the results.csv file inside the job working directory. So basically, when we are trying to get the job output download, we are giving it the job UUID and the output path, and it knows from where to fetch that output file for you. So it's just going to print whatever the contents of that output file for here. So if your job successfully completes, it should show you this output file. It may take a little bit for some folks, but it should be pretty quick unless somebody's running into issues. Okay, just wait a quick minute for everybody to run this job and see the results. Okay. So I'm assuming everybody is able to run the job. I'm not hearing anything on the chat here. So if you noticed here, we were polling this job to see the status, which might not be very efficient when you have like long running jobs. So in that case, basically what you do is you set notifications on the job events. So every time your job changes a status, you should get notified about it. And so currently we have this subscriptions thing wherein you can have emails or webhook notifications sent to you on all categories. You can even have specific statuses here, but you can, if you specify all, you would get notifications to your email. For example, if you provide your email address here, the notifications would start coming to you. And this has to be set when you run the job, so it cannot be set later or to a current job that's running. So if you notice here, like on the job submit request, we have these subscriptions wherein we say that we want emails, we want notifications for all status changes, and we want it on the email. So you can also specify webhooks to it. And when you run the job now, this time you should start getting those emails on whatever email that you have specified here. And this is again the same job, so it should be exactly similar, but the notifications should start popping in your inbox. The order may not be really same, like you might get the order of the statuses in which the job is running, but uh, because it's coming to your inbox, it might be like you get archived first and then finished, or finished first and then archived, something like that. Okay, I guess there is a question. Okay, I think it was just a follow-up question. Any questions on the notifications? Is everybody able to set up notifications or receive it as the job is running?
Is
Jack,
the
sorry.
Yeah, go ahead, please.
Oh, just quick question. Is a notification for each state change? And then we can also customize which state we want email, like if we don't want to see all state changes?
Yeah, exactly. You can specify from the category filter.
Okay, thank you.
We have more questions.
Annika, in the chat, Jack was mentioning not getting notifications.
Oh,
Are you still not getting them? Yeah, I see Nathan's responding. Okay.
yeah. So basically, when you are submitting your job, if you change the email address here in the delivery address to whatever email you want the notification sent out to, is anyone getting notification, or there is any issue with it?
I am not, but sometimes my email is a little delayed, so I don't know if it's a problem.
Okay, let me check my inbox. I'll just stop sharing for a quick second.
Looks like somebody got notification, so I'm sure it's working.
Joe, we have a question about whether we run a mail server or not. I guess like an SMTP server. I don't believe that is the case. Is that correct, Joe?
Yeah, we don't. Tapis does not, but we do have a relay server at TAC that is utilized for all of these things. And I do believe there have been some issues with oops, video wasn't on. I do believe there have been some issues with getting mail out to certain destinations, but I think it's fairly limited, in scope. So I hopefully all of you will get them. Okay, got it. Yeah, follow up.
Yeah.
Yeah, I mean, let's follow up with that. Yes, we can help you get that configured for sure.
I got 8 responses almost instantly. So I don't know if I've done something wrong, and they're still coming. So it's responding, but quite a bit.
Oh, you're getting duplicates, Rob?
I haven't looked at what each of them are, but yeah, now there's about a dozen of them. So they're coming quick and fast. They all they all have different UUIDs.
I believe Steve was saying that there's like an 8-part email phase if you don't try to like consolidate what notifications you're getting changes for, because as the job goes through its states, there's 8 of them. So I think that's generally what you should be looking for. And then if you wanted to prune that down, you'd go in and configure the notification stanza just a bit more.
Right. Like Annika was showing with the filter. So you can filter, the different state changes that you want to get notified for. And then if there are different UUIDs, I guess, Rob, the question would be, did you submit the job multiple times? Because then you would get notifications, you get all of the notifications that you requested for every UUID, if that makes sense.
Yeah, no, so I only submitted once, but they do all have new job statuses. So it does look like I'm getting each status. Yep.
Yeah.
Okay.
Yeah. Okay. Awesome.
Yeah, I mean, email is easy thing to demo in the workshop, and in the tutorial, but typically, I mean, sometimes people want email, but a lot of times what people want is a webhook, right? And so that's the other mechanism by which you can get a notification is a request, basically a request to a URL you specify, and that can be obviously that can be a lot more amenable to high volume of notifications.
Okay. Awesome. Thank you so much, everybody, for confirming that it's working for you. For some of you, if it is slow, it will come eventually. So just keep looking at your inbox. Last thing I want to quickly mention, because I want to give enough time for Christian to go through the wonderful stuff for pods, workflows, and TapisUI, is you can cancel a job if it is not in the terminal state. Let's say if you figure out that this application is not going to work and you don't want to waste your resources running that particular application, you can cancel it if it is not in the terminal state. And similarly, another useful thing that you have with systems is like you can share your systems publicly or apps publicly and with your colleagues or to specific users so they can reproduce those experiments and basically share all the results. So I think with that, I'll stop sharing and I'll hand it over to Christian for the next interesting part of this tutorial. Thank you.
Hello all, I'm Christian. I'm also here at TAC. I am going to share my screen. Make sure to let us know if there's any issues in the chat and we will get to you. 1 second. That's it. Okay, this is the wrong slide. Here we are. So as you might have noticed, there's been quite a lot of JSON, a lot of curl, a lot of requests, things that you couldn't really get maybe a incoming user or someone that's not really familiar with these technologies to get their head around. I'm a very visual person. I like to see things. I like to know there's a list of things out there somewhere and what the list kind of consists of. And so what we did, and this started a long time ago, I believe in 2019, TapisUI and Tapis TypeScript was a project started. It was not used for a bit, but then this past year, this past 9-10 months, great work from Nathan, our interns, everyone at TAC or everyone in the CIC group and anyone who else contributed. We've been working on a TapisUI. This is a React-based, a TypeScript-based, trying to be completely serverless API front end. So we're not actually running any server. We're not running any server. We're not running any additional functions outside of the APIs. We're still going to be using systems, files, apps, and jobs like you've seen, and then we will see some more. And what we're trying to do is give users, incoming users, people that might just want to see your results, see results from an experiment, etc. We just want to give them a way to get in quick and get access to the things they have. We're trying to make this I'm trying to make this, and Nathan, I'm sure, is very much trying to make this a developer-centric thing. So we're trying to add our endpoints, everything. But as you've noticed, there are quite a lot of little functionalities everywhere. And so just be aware that if you're trying to get the full potential out of the Tapis APIs, you are going to want to go the API route. If you're going to want to try to create processes that just work over lots of systems. And it's always just to note before I say anything, and please ask questions if you ever get confused. It's always slightly difficult to give explainers on a front end. Trying to get people to the right buttons and to see the correct buttons is always a difficult task. We're going to be trying to create video guides in our documentation for these kind of things, or at least on the most important things. That's not currently there yet, but this is available. I think it's available and very useful. And we're going to be trying to continue on this road. So yes, we can use all the HPC resources like you saw. This is just Tapis at the end of the day. In 2023, like I said, we had started for a lot of our APIs, the 4 main ones, as you've seen: systems, files, apps, and jobs. We created a UI out of them. Like I said, going into this new year, this is already old, surprisingly, only 2 weeks later. We have brand new interfaces for all of our things, or at least revamped interfaces, trying to make things easier, trying to make things nicer. And we'll be going through all this here in a second. Here's a little bit of a GIF, just to have as the background. But what TapisUI is trying to do is try to bring all of our APIs into one place. But that also means we're trying to make other APIs easily integratable. We're trying to create a plug-in system where, in this example, you can see at the top left, this is an ICICLE, like Joe mentioned at the beginning, portal dashboard using TapisUI. They've introduced additional components. I'm going through a few of them. I believe 3 of the 4 tabs are ICICLE only. And so we're trying to create a way that users can get into JavaScript, get all the niceness out of being able to be like on the latest React and latest libraries, contribute work, and have that actually be usable immediately. And so, like I said, on those 3 tabs that are from ICICLE, they're one page, they're one file contributions, and it just works. They get a tab, they get everything. You get authentication when you come into this, and we'll go through that. There's no actual real demo here in terms of you guys going along, but if you guys want to, or tutorial perhaps, but if you want to go through everything, it will be available, and I'll be talking through that. But feel free to just focus on the amount of information I'm giving. So with that, I'm going to go into TapisUI, and I'm going to resize everything for that. 1 second. So we should now be able to see slightly more than a browser. Okay. So I'm logged in here. I'm going to log out. So where is TapisUI? The first slide said it, but it's training.tapis.io. We've been talking about this tenancy model. We have multiple tenants. Each tenant gets their own TapisUI front end. It's not really a separate thing. It's just you can access each tenant at the URL that you are given. So because we're in that training.tapis.io, you can go to training.tapis.io. You should be dumped into this screen. You can press the proceed to login, log in with the username and password, and then you can give your it's gone. You can give your Gateway's training account username, password are the same thing. So I'm going to be logging in as what we were working with, but you can use Gateway's 24 training XX, and then the same thing as the password. After that, you can press login, and everyone should be able to get in. I'm going to give that just a bit of time. Let that go in. I'm going to make sure I have chat up. Yes, thank you. Okay. And so I just wanted to go over a few things before I go through all the tabs. At the bottom left, you can see that there's a little modal, a little button to allow you to view JWT. If you bring up this page, you can see that access token that we were working with in the Jupyter environment. If you wanted to, you could grab access tokens from TapisUI and not have to go through TapiPi if you're trying to do something with curl quickly. You can see what those claims are here. You can see how long that token lasts. You can change your tenants, so you can see all the tenants in the current environment. You most likely don't have access to very many. Generally, if you wanted to start working past the training tenant, you would use tap.tapis.io. But then I'm going to go into systems. I am that Gateways 24 training 75 user, which we were running the sentiment analysis with, and we had systems created for this with. If you were going through the entire process with us, you should see us, or you should see 2 systems here, or 3 or 4 if there was more that you made in the back end. But if you press launch system, you can see your systems, you can see public systems. I believe you all will have public systems here, and you can see your deleted systems. Yes. Once you press on a system, so this is that gateway's training 75. This is using that same IP like we all saw. It's 1, 2, or I won't say it out loud. But this is that system. If you wanted to see what the actual JSON was, if you wanted to see the code, you can have this like hide view JSON button at the top right. This gives you that verbose description of that system, and allows, you can imagine allowing or adding someone to a system, sending them to this page and saying, go view the things that you have access to. And hopefully they'll be able to get somewhat of an idea of what they have access to without knowing the full API list that we have and what you need. We have a trouble logging in. I would say to make sure that the username and password are exactly the same, not using the VM password, but Nathan or someone will, I'm sure, check it out in case it's something different. We'll try to get on that. Yes. Another interesting thing here at the system level, I have these 2 systems and I can see that I'm already authenticated. I get a little check mark. If you created a system and you haven't been authenticated with your token yet, you can press the authenticate button. It'll tell you, and you can set up the password and credentials you need to get into the system. This is a password auth method, so you would supply a password. We have no token one, or yes, maybe here. No. That's fine. If there was a PKI, if you needed your public key and private key, it would prompt you for that. It'll take it, just copy paste it. You don't need to do any formatting at that point. If you don't have access to a system, you will not see this view files button. But if I do go back to the system that we created during our tutorial, we have this view files button. You can go to it, and this is actually going to dump you to the second tab, which is our files tab. On the left, this is the systems that you have available to you, and so I can go through them. But as we saw, if I go from the systems view, I'm dumped directly into the system that I'm at. I can, in this view, and I'm just going through and demoing this, you can go through your files. I'm going to home. You can see that there's several users on this system. I'm going to go to training 75 because that's what we were using. But I'm sure, yeah. So I'm going to go into training 75, and I can see information from that job. We can see our UUID. We can see going in, outputs. At this point, you'd be wondering, okay, if I can just see this, that's fun and nice, but it's not horribly useful. But we actually have, like Joe and Annika said, we have several we're trying to get POSIX like operation through an API, and so you can delete files, a set of files, you can upload files from here, you can do that maker, you can do a folder operation or folder creation operation, you can transfer files between systems. We have Globus transfers as well. For a Globus system, you can copy and paste files. We can move them around just here. And then, very importantly, let's see, this isn't our exact UUID for the job we created, but we'll get to that soon. But if I wanted to see what this Tapis job SH was, I can press view and I will, okay, SH is actually, I forget. SH is a special case and we will work on that. But .env, you'll get your environment. You'll see your text here. If there was images, you'll get your images here, your videos. You can go in, see a CSV. Like you saw from the sentiment analysis, we can now see in well-formatted non-Jupyter cells the results from that. Correct? And I will stop there and maybe ask for questions at this point, just because I'm about to go into even more. So if there are any questions, I will give you 20 seconds, 10 seconds to bring them up. Okay. Cool. Thank you guys for helping with the chat. Okay, I don't see anything else, or files download to users. That is correct. Yeah, so I'll show that. So we have a download button, we have the upload button. Upload's going to be from your user computer. If I do this, I will get my file upload from whatever your operating system is and however that wants to work. A download is going to be a download to your operating system as well, just through Firefox in this case. But you should be able to grab files like this. I believe we can allow you to, yes, you can download a zip of a folder. And I'm aware all this is available through the API. It's just, like I said, we still have to get all this functionality into the UI. So there's sometimes things that aren't there yet, but downloads are working for files and then also zips for entire folders. And I believe that's the only two cases. Correct. I think, yeah, we'll talk to Amit if you need anything afterwards. I'm sure we'll talk a lot. Okay, so I'm gonna go on to apps. So if we remember, we created an app during the tutorial. If you want to again see, there are public apps. This is a training tenant, so you can imagine that if you were in a tenant created by DesignSafe and you were part of the DesignSafe group, you would get the apps that are available to you that someone, your admin, gave to you that you can run without very much bootstrapping. But we can go to My Apps. We can see that we have these apps that were created. We have an app job launcher that allows you to go in. It forces you to select the things that you must. And then if you skip to the end, it will give you the job that you're going to send out. And you can press submit job. I won't do that at this point. I will do something fancier later. But if I go back to the jobs, so sorry, I said if I go back to, but if I now go to the jobs tab, we can see the jobs that are going to be the invocation of said apps that you guys were running. But if I go to my latest job, ran at 1914, which is like it's going to be at 14, whatever time zone you feel like, you can put the first number. But you can see again the results from multiple of our jobs, very easily accessible. If I go to the most recent one, I can go view that CSV, see the results that we had. You can view your Tapis job out. Yes. So that's everything that you've seen so far, but now in UI. And so now I'm going to go into some other things very quickly. So I work on alongside the Tapis team, or as a Tapis developer, is a thing called the Tapis pod service. I won't actually go into this very long, and I'm not going to crop to just a thing. Sorry. Or maybe I can. I don't want to be. But this is the Tapis pod service. This allows users to deploy long-running Kubernetes pods through our APIs, or through a new API called the Pod Service API. We support Neo4j, Postgres, GraphDB, Flask. These are going to be Docker containers that we create for you that we can allow you to have for a long time. Conditionally, we can allow GPUs. But I will take your container. I will ask you some specific information on what ports, what URL you want to use, and then I will proxy that through traffic, which is a nifty and useful, powerful proxy that I've taken liking to. And I will give you access to your pod over the internet. And that's kind of it. We have volumes and snapshots as well for persistent storage and saving of persistent storage, maybe backups. Yes, going on to the next slide. This is just a cute little example of what is possible. So we have this, I'm going to go back to the Tapis client syntax for TapisUI, but we have this t.pods.createPod. This can take a simple pod ID. It can take a template. A template is going to be something I describe in the next slide, but that's going to be something that I can preload, or you can preload, or you can create for yourself, that allows you to basically start up a container with all the settings that you might need, especially for setting it up for the internet. Here, for example, we have Neo4j. Neo4j doesn't, or Neo4j is a graph database solution. You can think of it as SQL or something, or you can't. You can think of it as Postgres, but made by, I don't want to say this because it changes. But it's a graph database solution. You can start up a Docker container. It'll give you a cipher queryable endpoint that allows you to talk to the graph database and essentially get this end result of nodes, relations, and directionality between everything. Yes, once you create that pod, at this point, you can kind of just forget about the pod service and just know you'll have a pod. So I won't get into much more. There is one more slide here. Quickly going over templates. Like I said with that Neo4j example, sometimes things are complex. So going back to Jupyter very quickly, let's say I want to create a Jupyter lab. In the pod service, I can specify a Jupyter template in my pod definition. Inside of that template, you can actually define other templates first off. But then you can add this base template. You can see actually specifies the image, the description, the environment variables that we need, the networking and everything. You can use that template to add in extra volumes or other things that you might need to define for multiple users. And then you can use that in a pod to start it up. So I'm just going to go into that now with the UI. So going back to the training tenant, if I go to the pods tab now, we are at 36. If I go back to the pods tab now, I can see I have a gateways 1 pod. Everyone should have this, I believe. If you go to this perms button, you can see who has permissions to this pod. I've given training users 1 through 75 user permission. So you should be able to come in here. You should be able to see the details of your pod. This one is a fast API health check pod. This is just a fast API server. This is a Python API framework. It's just going to say hello world to you whenever you bring it up. But if you go into, so that's the details, that's your pod definition. If you go into derived, which is going to be the derived product of your template and your pod, you can see exactly what's being actually set up on your behalf. So for example, I get the networking stanza here added to my pod, even though I don't define it because it's defined in the templates. But I would note that if you had something in your pod, it overwrites that template. So I have my own description here as the description. But if I go to the derived tab, I still have that description as the description, even though new tab here, I'm going to go to templates at the top. I'm going to go to templates. I'm going to go to that template, and I'm going to see that the descriptions were very much not my my description, my custom description. They were already set. You can see your templates here. Templates aren't really deletable at this phase because we want to make sure that we have reproducibility going into the future. Yes, I also want to mention we have images tab. So if you wanted to stand this stuff up, or you wanted to create a tenant and only allow users to some images, this allows us to do that. We basically give a allow list of what users can and cannot run. I generally try to make sure I understand what's happening and how it works. But we also have users standing up their own APIs based off of pods. We'll see that later. Very quickly, I did want to mention, and I had set this up on another account, and so I apologize. I'm going to go to the second window. I'm also logged in as Gateways Training 1, but that's just to see. I have in my Training 1 account I'll bring this up. In my Training 1 account, I have a volume already defined. I can go in and see there's no files in this volume, but I can see that there's no volumes in this other one. Yes. And then I also have snapshots, and that is a saving of a volume. Yep, we'll leave that there. And then the next part of this is going to be workflows, which I do not believe we have slides for, but I will talk about it through explanation of one more thing in Tapis. We haven't brought this up, but Annika brought up our documentation. We're linking to that in like the end slides. But this documentation page, or read the docs, quote unquote, this is a story kind of trying to explainer of everything, but a lot of our APIs have very full-fledged support for open API specs. So if I go to, I'll link this in chat just so I'm not rude. If I go to here and I go to, you can go to many tabs. If you go to actors, I can see all the endpoints, all the functionality, all the things that I have to define for all of my API endpoints. So if I go back to workflows, or I can go to pods very quickly because I showed that t.pods.createPod. I can go to pods, I can go to create pod, and I can see exactly what I can give, exactly what it means. Yes. Alongside the documentation that is a little bit more story driven. I wouldn't say story in particular, but it's not written by the API. But this allows users to really figure out exactly what they need, find the little nitty gritty arguments that they might need. But going back to workflows, we have workflows. This is quite a large API. We have the ability to run pipelines, ETLs, tasks. We can archive pipelines. We can share our pipelines. We can create groups and share pipelines within those groups. A lot of complicated things. And I just want to say that is, I believe, the key use of TapisUI, trying to obfuscate our APIs, which are truly very useful and can be very generic, in a way that is more useful. Nathan Freeman is the one that's been working on this. He's the owner of workflows, and he's been helping a lot with Tapis. He is TapisUI. But if I go in here again into my training accounts, if I go to workflows, this workflows tab, everyone should be inside of this Gateways 24 group. If I go to it, you can see a list of all these training accounts. So everyone should have access to this, but I can go to my pipeline, this blank example pipeline, and I get a little GUI interface, a cute React Flow interface that allows us to see 2 tasks, environment variables, and arguments. These tasks you can think of them as arbitrary functions. Currently, these are 2 Python tasks. And so they're going to run Python containers on your behalf, run through everything, and save information at the end of them. But all of this is not in systems, and this is not going to be on your own host. This is going to be in our own Kubernetes environment, key asterisk. But if I see here, I have this arrow from the left to the right. I can see that through the arrowhead. If I go to this Python print to standard out task and I press this edit button, I'll get thrown into a pipeline editor. Here I can add information to descriptions. I can write information to run. You can run any type of Python code here. I'm running very simple code just so it makes sense. But if I said hello, newer demo, you can see that you should expect this to, for the question, Nathan's going to answer you on that one. This is going to print another line to standard out, very simple Python. I can press the save button. And now that code is going to be what that task is. If I go to inputs and outputs, you can define inputs and outputs from other tasks. You can define them from secret environments. You can define them from just environment variables that the entire task has. So for example, if you wanted to bring in some URL that you wanted to call and scrape every 4 minutes, you can define that in an environment variable and grab it here with a context dot, I believe it's context dot get context. I kind of forget, but I'll show you a fuller example here in a bit. If I go to the execution profile, you'll see more about execution. Nathan's implemented some retry policy stuff. So if something fails, you can try it several times if that's the kind of thing you're going for, or not at all. We try to make it up to you. This is dependencies. And so I'll skip that very quickly, but remember dependencies, you can say that one task is dependent on another and they won't run until the first one runs. So you can say, I need this to run, I need it to grab data, and then I need to check that that data is good before I go to my third step or fourth step, whatever you want to think about. We have this runtime tab that allows you to change your runtime. Currently, only Python 3.9 is in full production, but we have support for lots of other things. And if you need anything, please just reach out, mainly to Nathan. But I can definitely throw him your way, or yeah, throw him his way. You can install packages at this point. We know TapisUI is on PyPy. You can install Py2 Neo, you can install NumPy, you can install whatever you want. And you can remember this task is going to be set it and forget it, and you can share them. So everyone that installs this stuff and runs this task will have all the packages that you need. You can define specific versions as well. And I'll press save on that just for fun. You can also import GitHub repositories. This is my username. I can grab from any of my repositories a specific branch, and I can mount it into my task execution container as a certain file name or as a certain folder path. So my repo is going to be here. And then I can press that update button. You can see, or I can see, but you can see there was a save button. You can see that things were updated successfully. And then a full code view. So if I go back, and sorry for all that, I'm going to go to this second task very quickly. And I want to come back to dependencies, but you can see that the second task depends on Python prints standard out. And if I go back, this is what's going to be informing this little arrow. And so you could add tasks and do whatever you wanted. I am running low on time, so I must continue. Okay, so we know I changed the standard out prints from that first task, and the second task has a very basic standard out print as well. This actions button is what allows you to add new tasks and allows you to run your pipeline. If your tenant supports it, you can also get tasks that other people have already defined ready for you. So for example, in tac.tapis, we have a task already set up to authenticate with Tapis. We have a task set up to start a pod. We have a task set up to stop a pod, and you just set up the arguments and environment variables that you need, and you bring it all in, and it works. So I'm going to run this pipeline very quickly. I can just press run pipeline. You can add arguments at this phase in case you wanted to add a URL that's going to be called somewhere else. But then you can also set workflow or pipeline defaults through another means that I won't go into. We can see here at the top, we're going to need to go back and back. We can see here at the top, we have some logs. I can see that there's a failed pipeline, so this is probably going to be my fault. But this runs tab is going to be one of our most important. If I go to runs, I can see all my old runs. I can see when they executed. I can see a little green bobble and status. If they're successful, you can see a little red bobble, and failed if they aren't. But if I wanted to see more, I can press this little view button at the top right, or it's bottom right of each accordion. and I'll do that now. I can see that, look at that. I can see that there's two tasks. There's task ID 1 and task ID 2. Task ID 2 is in pending because task ID 1 failed. So that's the conditional part of it, or the dependent part of it. 2 dependent on 1, 1 failed. And then we can see our standard error. If everything worked successfully, it would standard out would be the print that we had. The standard error here is that I set a incorrect Tapify version. So that's just my fault. But now I can see that. I can see other users, if they ever ran into this, I can see what issues they have, but it going to a successful one very quickly. You can just see, you can get your standard out in both cases for this, for 2 different tasks. Okay. Yes, I know that was a lot, and I apologize, but I hope you feel informed. I now want to go into one more API. This is ML Hub. This is a little bit more starting out. We're trying to generalize for a lot of ML workflows, how to exactly grab models, run inference, and get things in HPC quick. And so we have this ML Hub API that allows us to grab information from Hugging Face. We can go into one of these models, for example, and we can grab information on what this transformer was, its repository contents. We can see information about the inference server. We can download each of the files in inference server if we need. And we can view the model card off of Hugging Face if we need to. But this allows us to actually, and I also say we also have data sets seen in Hugging Face here. But this allows us to go to something I'm about to go to, which is going to be in a new tab. I just switched tabs to a more useful to me tenant because training doesn't really have very much, just because it's good to keep things isolated. But in this ICICLE tenant, like I showed earlier, this is going to be a dashboard. This is going to be a TapisUI with additional features for ICICLE. But we allowed them to have this Jupyter Lab thing that's actually going to be running a pod with Jupyter Lab started on it, but visible in TapisUI. But inside of that, I'm just trying to get a way to show code to y'all. But I'm going to try to show me using that ML Hub and what it can do. Inside of here, we have a little import Tapis. We've seen this before. I'll zoom in just a bit, making sure you guys can see everything. We have an import for Tapis. I can log in here. I already have logged in, so I won't run that again. I can see I have my token here. It'll die in 4 hours, so yes, hopefully the recording isn't up before then. But I can now see this training.tapis.io v3 ML Hub models API. This is what the ML Hub is. It allows you to, whenever you run it, oh no. We will do this once more properly. I understand why. 1 second. This is token. Yes, okay. So I can grab that model list like I showed earlier. This is fetching the top 100 downloaded models. That's not inherently very useful, but I can now go to the inference API, which is a part of the ML Hub that allows us to grab available models to actually run inference servers for. And so if we have the capability to run an inference server for something inside of Hugging Face, we will give you the option to start that model up in a container that we start up in pods, either with or without a GPU, so you can run things from Hugging Face easy peasy. But if I go in and I say, so I have this available models, I have Google Flan T5 large, I have a Grammarly text model, and I have a VoiceLab model. I can take this Google Flan one, copy it, add it to my ML Hub inference endpoint here, call, And I can ask it a prompt of what is the capital of Finland. Again, I'm using a Tapis token and everything, and I'll post that. Give it a little bit. It's running. It's running. And then I get a little results. I can see that I get a result of Helsinki for the answer to that question. And I can get device information just in general. Yeah, and so that's the ML Hub, allowing us to run several different models. Hopefully making us more, hopefully allowing us to expand into further and different models, trying to create solutions for models that might not actually be like as easy to use. To which I'd say if you, to which I'd say we have this in pods. Pods is what I'm trying to create as the generic, give me lots of functionality from the open source community quickly so that we can build off of that and build infrastructure that works off of that. I have this open web UI and OLlama interface with the pods API that's using a GPU to serve up the transformers models that I've come to know recently, Llama 3.1s, Lava's Phi. This allows us to use the pods API and open source tooling to do the things that we already know how to do well. And then whenever we need to do new transformers or new models that might not work with Hugging Face pipelines so easily, maybe like the sentiment analysis, we can have this inference API to allow us to start things up and give you an easy way to talk to your APIs. If there's nothing more, or I would like to now ask the group if there's anything else at this point we need to talk about. I believe I tried to cover most of this.
Yeah, Christian, that was awesome. That was so cool. Thank you. And there have been a lot of excellent questions in the chat. Thank you all so much for all of those. Keep them coming if you have more. I can't summarize all of them, but I will say that just highlight a couple that were asked. One was asked about how do we create a Tapis tenant. And so if that is something you're interested in, please email us or join our Slack team or whatever they call them, Slack thingy. tac-cloud.slack.com is the TAC thing, or is the Slack thing. And we would love to hear about your project. We can create tenants for free. That was another question that was asked. What's the cost? We can create them for free. They're just logical things. They're just records in a database at the end of the day, basically. So we can create them for free for you. We ask that you meet with us so we can just understand what your project's needs are. And, there are aspects of the tenant that you can configure, like the authentication sources. Do you want to use TAC accounts for your authentication? Do you want to use CI logon or in common accounts for your authentication? So there are some things like that, which accounts should be the admin accounts for the tenant. So we asked that, if we could just meet once, we can get that set up for you. Another great question that was asked is, how does Tapis, well, I'm paraphrasing a bit, but how does Tapis kind of relate to getting access to, various computing resources like NSF-funded, like access allocated resources, or the LCC, the leadership class computing facility that we're deploying at TAC? And the short answer is Tapis isn't involved in that, actually. It's a middleware. And so really the I guess if you want to call it the onus of obtaining access is on your. We're happy to help you. Certainly for the systems that we run at TAC, we're happy to help you, with that allocation process, but that's really not a part of what Tapis does. Tapis is just a middleware that kind of, helps you helps you utilize access to systems that you already have access to in other ways, if that makes sense. With that being said, we do have communities and projects that are running on Tapis that do provide public access. So Design Safe is one example. ICICLE is another example. If you're interested in collaborating on those projects, There are public systems and public resources that are available, when the usage is appropriate for those projects. And then there were a bunch of excellent technical questions about like workflows and things and how those work. So see the chat for that. I won't try to summarize all that.
We also have a question about whether SSHD needs to be running on hosts in order to establish connection. It's only SSH, right? I don't think we connect
Okay,
any
that's a
other
great question.
protocol.
Yes. Well, mostly yes. Mostly yes. I mean, SSHD is probably the primary mechanism by which we interact with systems. And so we do need SSHD running on that host. Of course, there are systems for which sorry, I'm trying to read the chat and talk at the same time. That's not a good idea. There are systems for which SSH isn't supported, like S3 buckets or iRods, right? Globus endpoints. So those things don't need SSHD, but yeah, by and large, outside of system types that don't support SSHD by their nature, we do need SSHD running on the system. Hopefully that answers the question. And then Jack asked, is ICICLE public access? That's a good question, Jack. I mean, yes, Jack, if you want access to ICICLE, feel free to reach out and we can make that happen. But I mean, in general, we're sort of in an early kind of preview stage. We're absolutely looking for collaborators though. So yeah, that's kind of the situation there.
Well, thank you so much, Joe and team. And I know we're at our time together today, so I just want to make sure that everyone has time to thank the team and just very appreciate everyone's contributions for a wonderful tutorial. And I did pop into the chat an evaluation, so we hope that you do share your feedback and thoughts about how today's session went and any ideas for maybe some things that you would like to hear from future Tapis tutorials next year.
Yeah, thank you so much, Claire, and thanks everybody. Hopefully we'll see most of you in Bozeman next week as well. Very excited to do that. So thanks everybody. We really appreciate it.